we are going to start. Okay. For before knowing, you are seeing my slide presentation, right? All of them.
Yes, yes.
The piping layout and piping flange material. That is a slide I am presenting. Okay. So here, be a stress engineer. Here must know basics from the layout, that material point of view, and everything. Then only can become a best stress engineer. So okay, for that, first of all, I have small questions for the GETs. Can anyone tell me what is the difference between the piping, and pipeline? Anyone, guys?
Mr. Leo, here we use term UDs instead of GET. Okay, so you need to UDs instead of GETs.
Okay, UDs. Okay,
Yeah,
UDs.
UD.
Anyone can tell me, Mr. Abdullah or Jasim or Kalpesh? Anyone can tell me what is the difference between the piping, and pipeline? Everyone unmute, please, so we can. It's like a discussion and a technical conversation we can make. It's not like a full lecture. I'm going to speak. It's like a question and answer only, most probably, because we are all working professionals. So all can unmute, and so we can have a discussion. So technical stuff. Can you everyone unmute, please? So accordingly, it will be a good conversation and a discussion. Yeah, right. Because it's like a technical discussion. Most of the topics like a technical discussion only. So unmute and we can discuss, and you can ask, and you can stop me at any time, and you can ask your doubts, everything. Like that only the sessions will be going. Okay. So now anyone can tell me what is this pipe and piping and pipeline? What is the difference?
Pipe is just
Can
what
you
carries the fluid, and then if you have a pipeline, it's the actual pipeline with the whole flanges and pumps, valves connected.
Okay, like Abdul said, so pipe is a hollow cylinder shape. It's made of any metal or a non-metal. In that, we are transferring the fluid, whether it's a gas or a liquid, whatever it may be, from one place to another. It's just a component. It's a single component. It's a hollow cylindrical shape. That is the pipe. Piping means it's a combinations of components like pipe, fittings, flange, elbows, valve, T-bolt, and everything. It's like a piping. And a pipeline, it's a long run pipe that will convey the oil or gas from one place to another place. It's a long distance travel. That is called pipeline. Okay. And now the next small question. Anyone can tell me what is upstream, midstream, and downstream, which we are using in our oil and gas? What's the difference? Jasim, can you try?
Upstream.
Yeah, anyone, please.
Upstream is when you extract the oil or the gas from the ground.
Okay.
Midstream is the transportation process, and downstream is the refining process.
Yeah, you're great. You're right. So that's the thing. So upstream, it's the exploration and the production. That is the main thing which is going to happen in the upstream. So whether in the upstream, it will be the onshore or offshore, whether in the land surface or a sea bed, wherever the exploration and production which is going to happen is called upstream. And then midstream is the transportation, maybe through pipeline or through cargo ship or any tanker, lorry, or whatever it is. Based on that, we are transferring the fluid from one location to the other location. From the upstream to the downstream, we are transporting the fluid. That is called midstream. And then, as you said, it's a downstream. Here, the refining process, the petrochemical plant, the refinery, everything is going to happen. The crude distillation has to going to happen. From the crude, the petrol, diesel, kerosene, naphtha, butane, methane, propane, like that, all the things will going to get it. That is the downstream. Now we will come to the some materials suggestions. There are materials means piping material, maybe the ferrous and non-ferrous material. Like that we can differentiate. And also the non-metals. Most probably the main ferrous which we are using in our projects are the carbon, alloy, and stainless steel. This is the main thing. For that, there's difference. What does the difference means? You see the carbon steel which we are using for the temperature range from minus 29 degrees Celsius to 427 degrees Celsius. And even though up to minus 46 degrees Celsius, we can use the carbon steel. Anyone tell me what is the spec for the carbon steel? What is the spec name? Can anyone tell me for the low temperature carbon steel? What is the material spec name? We have A106 grade B, API 5L grade B, like that different materials we have, right? So for the low temperature carbon steel, what is the material? Do you have any idea? Anyone? Mr. Manoj, can you tell me?
A333 grade. We're
Yeah,
using
you're
for
great.
pipe.
That is right. Yes, you are right. So, like that, many different materials. As a stress engineer, we must know what is the spec and what is the combination to create that spec. Like that, each and everything, and for which temperature, what is the material. So, like that, the differentiate the stress engineer has to know. Maybe this is the layered point of view, but the stress engineer have the knowledge about this material differentiation for different things. So here we have the other combination with the cast iron. Some components will be added to get a new alloy material. Maybe a nickel or chromium or silicon or MO, like that. Many things are we are adding to get the alloy material. Why I'm telling like this means, if you see the code books, I'm just sharing one code book. So this is the code book which we are using for the flanges B16.5. Mr. Manoj, you are working with this ASME code books only, right? The projects, everything with the ASME and API code books only. Am I right?
Yes, yes, right.
So that means we can, because some companies are working with the British standards like that. So that's the reason I asked this question. So here for flanges, if you're working with the flanges, the code book is ASME B16.5. If you go inside this code book, you see there is a groupings will be there. What is the forging, casting, and plates like that. If you see here, different destination is there. CSI, that means silicon, manganese, or carbon or vanadium, like that. The combination, this combination create this material. So A105 means is a combination of the carbon and the silicon. So A350 grade LF2 means is a combination of the carbon, manganese, silicon. So like that, the combinations are there. In that, what is the purpose of this combination? What is silicon? What is the usage? What is the advantage and disadvantage? What is the vanadium advantage, disadvantage? What is the nickel advantage, disadvantage? Like that, the small presentation now I'm going to share with you. Okay, so that is the thing, combination we get the different materials. Okay, and then the stainless steel. The stainless steel most probably we use where the more corrosion is there and more heat is there. So it's like a heat resistant and corrosion resistant means most probably we go for the stainless steel material. The temperature maximum above 530 or 540 if we going means that it will be a stainless steel. Okay. So now I'm going to tell one by one what is the purpose we are adding this silicon. What is the advantage of silicon? We are making a combination in the material means which increase the hardness and wear resistance. And this also have some disadvantage. If you add more content of the silicon, that means it will affect the plastic properties and the toughness also it will be affecting. So there is some limit in adding the thing. So we are not going to depth into the material. As a stress engineer, we have to get some idea about this. So that is the reason I'm sharing this content for you. And then manganese, Mn. Manganese, why we are adding is that it's increase the tensile strength and it also remove or improve the bad influence of the sulfur. So that is the advantage the manganese was adding in the material. And this also have some disadvantage. If more content of the manganese will added, will affect the welding properties and it also reduce the heat conductivity of the steel. So like that, sulfur also we are adding in our material because which improves the machinability. So that's the reason the sulfur was adding in our material. And this also have some disadvantage. That means if we have more sulfur content, it will create some impurity in the castle. And maximum we can maintain up to 0.04 percentage of sulfur in the material. Likewise, phosphorus which increase the strength and hardness for the material. And this also have a disadvantage means which reduce the plastic property and the toughness of the cast steel. So this also 0.04 percentage max we can add in our material. Like chrome which improve the hardening capacity during the heat treatment process. And this also have some disadvantage, will affect the plastic properties. Likewise, the mo which improve the hardening capacity. And likewise, nickel means nickel which improve the tensile strength and toughness of the cast steel. Vanadium which used to refine the grain size. So that is the reason these are all the things which we are making a combination with the carbon to get a new product. Okay, so likewise the products, as a stress engineer he must know what is the differentiate. The thing is the major materials which we are using in our project and sharing here. A53, A106, A333, these are all the carbon steels. And then the alloy A335, these are the alloy materials. And A312 is the stainless steel. So that is the differentiate. 335 means it's the alloy material, and 312 means it's a stainless steel. And the type will be the differentiate. P1, P11, P5, P9. Like that, the alloy material will be differentiate based on the temperature we are using this. And we can get all these details from a document that is called Piping Material Specification, PMS. The piping material engineer will create the document. I think everyone unmute because I am only speaking, but no one was. Whether I want to know some conversation, so please unmute, like a discussion, because everyone is the engineers, only piping engineers. Like a discussion, the technical conversation we can make. Okay, I think I next in another few minutes I make some cues. So I think you can have to puzzles are there. You have to answer it. Okay, so here some plant or some equipments or there means the main components which required for us is pipe. Anyone tell me now what is the requirement here? So Jasim, can you tell me what is missing here? Or Kalpesh,
Fittings,
yeah, what is the fittings here and there? Can you tell me here, what are the fittings? What is missing here?
elbow and T's. Elbow.
Okay, T's, reducers, like that many things are there. So here elbows and here maybe the T connection.
T junction. Yeah.
Reducer is there means different pipe size or the reducer will be there. And for this locations,
There can be two type of connection, either welded or flanged.
yeah, flanges. So flanges, there are different type of flanges. Anyone tell me what are the different types of flanges which you are aware?
Weld neck, socket weld, lap joint.
Okay.
Then again, based on the flange faces, raised face, flat face, tongue and groove, ring type joint.
Yes. So many things are there. Here, just a small thing. The most of the flanges, mostly we are using this weld neck, socket, slip-on, lap joint like that. Just an image presentation I'm showing here for our knowledge purpose. Here, this is the weld neck flange. Here, if you see, here there is a connection how it was making with the pipe means the butt weld will be there. Now, the V cut we are making, in that we are making the weld. So this is the weld neck flange. Look like this. And the socket means we are insert the pipe inside the flange, and there is some extrude portion that will stop the pipe to move further. So like that, the socket weld flange will be there. Here we are making the fillet weld with the pipe and the flange. This is the socket weld flange looks. And then the slip-on flange. The slip-on flange, how it looks means it's like a full round surface, and then if you insert the pipe, it may possible to come this side. So both the side we are making a weld. The fillet will be happen to make in the outside and inside. Both the side we are making this welding connection in the slip-on. And then lap joint means it's like a cup shape. So there is a extrude portion is there. So and here like the weld neck flange, we are making a butt weld here. The connection with the flange and the pipe was making as a butt weld. And the threaded flange, most probably in the oil and gas, the high pressure temperature piping, we are not using this threaded flange, but this is the presentation how it looks, the threaded flanges. And apart from that, we have bolt gaskets. This is the main thing which we are using to make the connection of the flanges. So all the flange to flange matting is going to happen with the bolt and gasket, and this bolt and gasket details has to be known by the stress engineer, because the stress engineer only going to do the flange leakage test, whether the flange is leaking or not or without leaking. That checking has to be taken care by the stress engineer. So as a stress engineer, he must know what is the bolt details and the gasket details. Here, most probably, we are using the A193 material as the stud bolt in the temperature like this. And then the gas to the spiral wood gasket or the, so like that many gaskets we are using now. And
I,
the,
I have one question on this.
yes,
Uh,
yes, yeah.
if we are going to cover it later, it's okay. What is the criteria to check flange leakages in stress calculation?
Yeah, that's only I'm trying to
I'll,
show. See, yes, that is the criteria. For that only I'm sharing this slide. If you see the slide, what is the content I have? Can you tell me? The pipe material, the flange material, and the grouping I mentioned. Am I right?
Yes.
Yeah. Why I make this table and I'm presenting here means, can you tell me from where I get this detail? From which document we are getting these details? This materials and all.
31.3.
Yeah, 31.3. As a piping deliverables, that's the PMS, right? From the PMS, based on the project, it's based on the specification, we are making the materials, grouping, right? That is the PMS, piping material specification. As a stress engineer, he must know how to read the PMS. And he has to note down if we are going to work with the 106 grade B material, means for that, what is the equivalent flange material? If you know what is the equivalent flange material, then only you can know how to select this group. If you know how to select this group, then only he can able to do the flange leakage test in Caesar software. So you can understand what I said.
Yes, yes.
That is the thing. So as a stress engineer, he must have to read all the documents. The process team will provide some documents that is called P&ID and line list. And from the piping team, the piping material engineer provide the PMS and the wall thickness calculation they are providing. And then the layout team, they have made the 3D modeling and they are producing the isometrics and the Navy's file and they are providing as inputs. So these are all the inputs and the PFD from the process team. So these are all the inputs. From that only we are doing the modeling part and we are doing the stress analysis. And why this material knowledge is required means without knowing the material we can't do the analysis, because based on the materials, the temperature, everything we have to design, right? The allowables, that is the main concern for stress analysis we are doing means there is some allowable limit which be there. That allowable limit is based on the material and the temperature only. Without knowing the material knowledge we can't do the stress analysis. So here I mentioned here pipe material, and that is the base, it's a carbon steel, and I mentioned the pipe spec B36.10. Can anyone tell me what is the code book for the stainless steel? These are all the carbon steel. For the stainless steel, what is the code book? I mentioned for
And
carbon steel. Yeah, come again.
yeah, 36.19.
Yes, you are right. So that is the code book which we are using. What is the purpose of the code book means? I will show the code book for your reference. See, this is the 36.10. For the carbon steel, we have this code book. You can able to see my screen, right? The PDF. Here you
Yeah.
see inside the code book, if you go inside, for the size, what is the size and what is the wall thickness, the schedule, all the details we are going to get from this. This is the standard, we can get it all over the world. If you are going to work for the ASME pipe, B36.10 means this is the wall thickness for the pipe. There is a schedules. We have the schedule. If you go for the 2-inch pipe, see this is a 2-inch pipe means we have the schedule 5, 10, 30, 40, 80, 160. If pipe 2-inch 160 schedule means the thickness is always 8.74. This is the world market standardization of the pipe wall thickness. There is a non-standard also is there. So that is not specified. Most probably the pipe wall thickness selection has to be taken care as per the schedule. Based on the pressure, the wall thickness calculation has to be taken care by the pressure. The formula which available from the code book. What is the code book? The pipe wall thickness calculation for the process piping, the oil and gas piping. From which code book we are getting that wall thickness calculation formula? Anyone tell me?
B31.3.
Yes, B31.3. That is the code book which we are using to get the pipe wall thickness calculation. So this is the B31.3 code book for process piping. This, as a stress engineer, he must know what was inside this 538 pages. This is a like a Quran or Bible or a Bhagavad Gita, whatever it may be. This is the main thing which required by the piping engineer, and all the formulas, definitions, everything which available in this code book. And he must know how to read this codebook. In the next session, I will tell you how to read this codebook and which is more important in this code. Okay, and here in this codebook we have the formula. This is the pipe wall thickness calculation formula which we are using in the oil and gas process. To calculate the thickness, the pressure, the dia and SEW we have. And what is that SEW means? You see, it is a E is the quality factor and S is the stress allowable value. The stress allowable value is the main thing the stress engineer has to know, because without knowing the stress allowables, you can't do any stress analysis. The details we are going to get it from the table A1M. That is the appendix A. We have many appendix in this code. If you see, there is a appendix in the index. So appendix A, B, C, D, E, F, like that many appendix are there in this B31.3. In this, each and everything is used by the stress engineer to do the stress analysis. I will tell one by one what is the purpose and everything. So here I mentioned that appendix A which give the allowable stress. That is the limit. If you want to do some analysis, there is some limit we have to maintain. If you cross the limit, our system was getting failed. If you within the limit, our system was getting passed. Like that only the stress analysis concepts are working on. So as a stress engineer, he must know how to read this appendix A. See, this is the appendix A. If you see, based on the material and the temperature, we have the allowable values. See, these are all the materials. Different materials are mentioned, the UNX number, everything, and then temperature details for this temperature and what is the allowable values. Like that, it was mentioned. So you see how many pages are there? Nearly 100 pages are there. We have to know how to read. If A106 grade B is the material means, for that what is the allowable? That we have to read. See, A106 grade A and this is the grade B material. For that, based on the temperature, so basic allowable stress, for the temperature we have the value. These are the allowable. A106 grade B means these are the allowables which we have to take care for in our season. So for each temperature we have the allowables. So what we have to note down is that we have to mention A106 grade B, the serial number was 31. So for this 31 we have to check the temperature wise. The next sheet we have the details. So the serial number was 31. For this 31, what is the allowable, which was in the megapascal, the basic allowable stress for each temperature up to 40 degree, the minimum temperature to 40 degree and Celsius and 65 degrees Celsius, 100 degrees Celsius, 150, 200, like that it was going on. For that 106 grade B material, what is the allowable? That means 138 megapascal. This is the allowable limit. We have to do the stress analysis and we have to maintain less than this allowables. Like that, the stress analysis we are going to do in the Caesar. I will explain that.
I have one question
And
in this.
yes,
As we see earlier, the carbon steel pipe we are using up to 427 degrees centigrade only, right?
yes,
I'm seeing carbon steel, not alloy steel, right? But if we see against the 31 serial number, the temperature range is given up to 600 degree for allowable sand. So can
yes.
you please explain a little bit more on this?
Yeah, that is the thing. Up to force 27, we can go for the alloy means. Here, what is the allowables means? 427. His allowable was less than 80 only. And if you have to take care for that pipe, what is the flange and the flange selection also we are taking care. The flange selection was based on the ratings. For that 106 grade B, for this we have some pressure. That is the details we are getting from this B16.5. We have to check everything whether the flange, all the fittings, everything has to be satisfied with that or not. The pipe material, the flange material, everything has to be taken care. So here also up to is there. The rating also will be different based on the temperature. There is a limit. That means exactly as a process layout guy, you have to tell me, because that selection has to be made by the process engineers. And there is a criteria 427 means that is the limit. That like that only as a stress engineer I have the idea about that. Why they can't go for above 538 means that idea I don't have, because that has to be taken care from the process. Am I right? So
Okay.
process engineer has to answer that, because that is the limitation up to 427 only we are going to the big But from my understanding, what I feel is that we can't take only the pipe material, the flange material, the elbows, everything we have to take care. Whether for that process also we have to on what is the fluid, that also has to be taken care. If it's a more high corrosion fluid means, even for less temperature, even for 80 degrees Celsius also we can go for the stainless steel material. There is no criteria. Up to 427 means we have to go for carbon steel. Not like that. If it's a high corrosion material, means then we can go for the stainless steel. Even as a water, just water, there is no temperature, just water, but it's a more high corrosion water or any fluid is coming means, then we go for the stainless steel. There is no limit. After 530 degrees Celsius only we go for stainless steel. Not like that. And
No,
also,
no.
exact,
Sorry,
yes.
sorry to interrupt. My question was different. Actually, the code itself is suggesting us or giving a limitation to use up to 427 degree, right? But in the code again, they are giving allowable up to the 600 degree temperature. So that was the confusion to me. That why at one end code is specifying that carbon steel can be used up to 427 degree, and then code again giving us allowables up to 600 degree.
Yeah, that's a worst condition, right? We can't use the worst condition in our project because the fatigue analyze everything we have to take in care. The lifelong we have to take care because the hertz are running means, for that there is a more flexibility and the pipe, the stiffness, everything will be reducing. That will not be standardized. So we can't specify up to 600 we can use the material. Like that we can't predict that. Because there is a maximum up to 600 we can use, but our for the lifelong we have to take means that we can't use the material.
Okay,
So
understand.
there
No
is,
problem.
that is the consideration, and even that is the my understanding. So for that, everything has some limit, and the fatigue analyze we have to take care. For 20 years, 30 years, the plant has to run means, for that whether this material can withstand. If you go for the worst condition 600 and the allowable was less means, if anything happens means that will not be acceptable, right? So we have to make some limit. So that is the thing. Up to 427 we can go for carbon steel. Like some limitation we are creating. We can't go for the worst condition. Okay. So now I mentioned here in the presentation the grouping. Here, why I written the grouping specifically means, as a stress engineer from the PMS, he has to know what is the material of the pipe and what is the flange material. And from this 16.5, this is the flange code book. Here, he must know how to read the grouping, because here the flange leakage test we are going to do in Caesar. So in the Caesar, we have the flange leakage test. If you are going to do the flange leakage test for any flanges, there is the option pressure equivalent method and NC method are there. In the pressure equivalent method, we have to select for this 106 grade D is the material means. For that material, based on the pressure and the temperature, we have to know what is the grouping. So if you know the group code, see this for the rating wise, we have to select what is the group. For A106 grade B, I mentioned A105 material which was in the group 1 is to 1. A105 which was in the group 1 is to 1. If you know this grouping, then only we can do the pressure equivalent method. So if we select this 1 is to 1 group, for that what is the temperature and pressure details, that will be come in this user. I will explain each and everything. Just for this flange leakage, Mr. Manoj asked how to do the flange leakage, what is the purpose, that is the reason I'm sharing here. If you see, compare this code book, this is the 1 is to 1 grouping for A105 flange. What is the temperature and the pressure rate? So for 150 rating for this temperature, this is the details. See, most probably it will be same. For 38, it was 19.6 that was showing here. So likewise, up to 538, what is the pressure? What is this pressure temperature rating? So these details shown here. If you know what is the pipe flange material, then only we will select the exact group, and from that exact group, based on the rating and the temperature, you will get these details as the input in the system. And if you know what is the cascade dia details, that will automatically come based on the material and the pipe dia. The gasket mean dia will come. So based on this, we are doing the flange leakage test. This PQ means is a pressure equivalent method. I will explain the formulas and everything, how this equation was worked out for the flange leakage. And there is a NC method. This is based on the bold details. I will explain in the further classes. Okay. Whether you can able to see my screen, the presentation slide.
Yes, yes.
So here, likewise for 106 is 1.1 means, likewise for 5L grade 60 means it's a 1.7 is a A70L3CL3. That is the flange material. And A333 grade 6 is the pipe material means for that the flange material will be a 350 graded LF. And the grouping will be 1.1 or 1.2 if this is the flange material. These details we are getting from the PMS. Likewise, there is a different materials. Manoj, whether you use these materials in your projects, B444, ACE, B72900,
No, sir.
because most probably you people are working with onshore only or offshore also your people are working offshore projects
No, we are working in refinery downstream.
downstream only. Okay. Okay, here these are all the materials I'm collecting from onshore, offshore, the downstream, upstream, all the projects. The reasonable materials which people are working. That only I'm listed out here. So these are all the B444 internal materials which we are using in the fixed platforms FPSO, that means the offshore piping. So these are the materials and just the knowledge purpose I'm sharing here. And you see for B444, this is the flange material for that the group code was 3.8. If you know exactly the 3.8, then only we can select in our Caesar the 3.8. So likewise, the difference material is there. And for UD people, you have to know understand is that for I already mentioned alloy means it's a A333 double 35 is the alloy material and A312 is the stainless steel. And by seeing the name itself, we have to differentiate whether it's alloy or stainless steel. And here it's mentioned P11 and F11 and P5, F5. So P22 is a F22. From this, we can have a differentiate whether it's a pipe material or flange material. And most probably for the alloy and stainless steel, the flange material will be in A182. So you see the combination, the A182 is the name and F11, F5 like that it was. And the grouping, the main reason we have to know is the grouping. What is the group from the B16.5? So likewise for different pipe material, different flange material and what is the grouping. The details the stress engineer has to know. Okay, and then walls. Just small idea about the walls I'm going to share now. The different walls which we are using in our projects, the gate, globe, check, like that many walls are there, and these are the some of the walls which we are using in our projects. Globe, gate, ball, butterfly. In that, the main 4 or 5 walls I'm going to share with the images. So this is the globe wall which we are using in our projects. Most probably for the pressure drop, we are using the globe wall. Mr. Manoj, I have a small question. Here, this wall, maybe the pupils also can explain how we are making the wall because if like a small pipe like this, we have to introduce pipe walls like this, and we have to introduce the wall, a globe wall. So A to B is the, and here the flow will be like this means how we are going to place the globe wall in the layout.
Yeah, we have to place it along the flow direction. So the B to A will be the
Okay.
direction.
Okay, that is a thing for the globe. What about gate?
Basically, gate
What?
wall doesn't require any in placement or in installation. There is no any specific requirement to install along the direction.
Yes.
So it's
For
a
NO,
bidirectional wall. Gate wall is a bidirectional wall.
yes. And NRV?
NRV is again NRV is again it need to be installed along the flow. So in globe
Yes.
wall as well as in NRV, on the body itself, flow direction will be marked. Flow arrow will be marked.
Yes. So this is the basic idea about the walls, how we are going to place the thing. So under the purpose we are using is the globe walls for the draining purpose. We are using the globe wall. Sorry, for draining we have the globe walls and drainment, and even for the pressure drop we are using this globe wall. Likewise, gate wall, which looks, and as Mr. Manoj said, it is a bidirectional, both the set. If you want to make a shutdown, if you want to make a switch on off like that, the process, if you want to close the flows suddenly means you can go for this gate wall. And then wall walls also we are using. This also like a sometimes if you want to make the control means we have a throttle. We can throttle it and we can reduce the flow, and even if you want to reduce the pressure also we can use these ball valves in some location. By making a small off way we can open the flow and we can make it. And then control valve means in the ball valve control in the globe valve we have the motor and actuator, and most probably this control valve we are using in the pressure drop. That means in the vent line, if you want to reduce the pressure from 2500 rating to 150 rating, like that, if you want to go, we can use this control. It's like a globe wall presentation only. In that, the motor, actuator, everything will be fitted under this arrangement. This for this to get this control one, we need the support. The piping team need the support from the mechanical engineers and then the instrumentation engineers, because the actuator, motor, everything has to be designed from them. Accordingly, this has to be taken care. For that, the data sheet preparation, everything to be taken care accordingly. So, and the check wall, just a presentation. Here, see, the check wall means is a non-written wall. If the flow was coming like this means this will be swing upward. So the flow will be going. And if the flow try to return means it will not return back because it will stop the flow backward. So like that only, most probably we have the thing. So in the check wall, we have the different types: swing, piston, and in lift. I have an exact image for this swing and piston. In the piston also, it's like a two-way stroke engine like that in our automobile. So you see, if the flow was coming like this, we will try to push the piston upward and the flow will be going. If the flow trying to return back, it will not, because the piston was closed, so the flow will be stopped and it will not return back. So this is automatically will going to happen inside the wall. That is the purpose this non-written wall we have. Most probably in the project, the feed line and in the end of the thing we have this NRV. So these are all the basic layout, and this is the piping, overall piping, the equipment, the fittings, the walls and everything. And now what is missing in our project here? What is missing? In this
Supports.
layout, what is supports? Yeah, that is the scope of stress engineer. He only going to decide what is the support and what type of support it is. Whether it's a shoe support or a spring or a stud or a trunnion, whatever the support. This decision making, what type of support and what is the gap for the support, everything has to be taken care by the stress engineer. So now, as a stress engineers, we are going to go in detail about each and everything about this. Now I share my Caesar. All the four, whether you done modeling in Caesar previously, experience about each and whether you have any idea about each and every icon and comments and tools. Any one of them has worked previously or any modeling work has done. So here I will close this and I will open from the first so far your explanation. So in your company, you people are working with the Caesar only, right? There is a different software server, AutoPipe, Row, like there is there. So you people are going to work with the Caesar software. Am I right?
Yes, our reports, I mean, our projects are calculated on Caesar only.